Let's look at this problem. We have this composite area, and we need to determine its centroid x bar and y bar. And because this composite area is symmetric about the y-axis, therefore the centroid location must be on the y-axis. And we know that for any point that is on the y-axis, the x coordinate is 0. Therefore, in this case, we can already tell that x bar equals to 0. All we need to do is to calculate y bar, which equals to summation y tutor a divided by summation a. So what does this equation mean? We can tell that this composite area is made up by 4 component areas. So we will have area 1 here, area 2 here, area 3, and lastly area 4. So for each of them, we need to calculate their its area, and also we need to determine its own centroid y location, y tutor. So which means that for area number 1, its own centroid is here at the geometric center of this rectangle, and this much is the y tutor 1. So we need to determine the y tutor for each of the component areas and then do the calculation to determine y bar for the entire composite area. So for this type of problem, it's easier to set up a table because we have 4 component areas. So we're going to have area number 1, 2, 3, 4 right here. And for the first column, we're going to calculate their individual areas with a unit of millimeter squared. So for area number 1 and 2, they are the same. So they have height of 100 millimeter with width of 20 millimeter. So that is 20 times 100, 2000 millimeter. Area number 3, we will have a length of 200 millimeter and a height of 20, so 200 times 20, that is 4,000 millimeter squared. And for area number 4, the vertical one, we have height of 260 and a width of 20, so 20 times 260, that is 5,200 millimeter squared. So that's the first thing. And then for the next column, we're going to calculate y tutor location for each of these component areas. So for area 1, we know that from here to here, that is 260 plus 20, that is 280. And from here to here, that is half of the height of area number 1, which is half of 100, which is 50. Therefore, y1 tutor equals to 280 minus 50. That is going to be, so actually, it should be from here to here is also 50. So 280 minus 50, so that's going to be 230. Which is the same for area number 2. So 230 here and 230 here. Area number 3 is going to be 280 minus half of its height because its own centroid location is here. So 280 minus half of 20, which is 10. 280 minus 10, 270. And lastly, for area number 4, its own centroid location is here. So this is its y tutor location, y tutor coordinate, and that is 260 over 2, so 130. So that's the next column. For the next column, remember we need to calculate y tutor multiplied by a. It has a unit of millimeter to the 3rd power, which is actually not very important. So we're going to take these two numbers and calculate their product. So 2000 times 230. So that's going to be 460, 000. Same thing, 460, 000. And then we have 1080 000,676,000. So what's next is to add the first column and the third column together. So for the first column, we're adding all the component areas together to get the total area. That is 2,000 plus 2,000 plus etc. etc. So that is 13200. And then we're going to add all these together as well. And that equals to 2676000 millimeter. Okay. So as you can tell, our y bar equals to the summation of y tutor A over the summation of A, which equals to this number 2676000 divided by this number 13200, and eventually that equals to 202.7 in the unit of millimeter. Therefore, the centroid location of the composite area equals to 0, that is x bar, 202.7 millimeter. So we can try to mark it on our sketch. So 202.7 is probably here. And that is the centroid location.